pick up where we left off. What's the calculator situation again? What kind of graphing? Do you have one yet, or have you not gotten it yet?
Not gotten it yet.
Because I was just on Chatfield's website earlier today, and I noticed that everybody must have a TI Inspire. So
okay, so I would definitely get one.
yeah, for sure. And the sooner you get it, probably the better, because I can help you a little bit with it. And there's going to be a bit of a learning curve on figuring out how to use it. But yeah, the sooner you attend to that, probably the better. They probably have some program. Actually, the reason I was on Chatfield's website was I was trying to figure out which book they use for their AP statistics. Wasn't quite sure how to get that information. I couldn't get anybody at the school to answer. Do you have any idea? Is there a way that you can figure out what textbook you're going to be using if you were, to take geometry?
Yeah, I'm not sure.
How do you figure that out? Because what I'd like to do is I've got quite a few students who are going to be taking statistics next year, and I've never offered to tutor statistics. So I thought I'd spend the summer reviewing the textbook, but first I got to figure out what their textbook is. So that's why.
Well, yeah, every time I've gotten a textbook, it's usually like the first day of school, and then you go into the class and have them.
So you don't get it until the first day of school. You don't get it a couple months early, or there's no website you can go to pick it up early or anything like that.
Not that I know of, because since that's how it was for me for middle school, I don't know how it's going to be for high school, but I would say definitely the 2 weeks before school starts. That's probably when the school is going to start answering. Before then, I doubt it.
Okay. All right. I'll just have to live with that. So I was just looking at these things they want you to learn here. We've written a linear equation using 2 points. We've solved linear inequalities, pretty much the same as solving a linear equation, only it's an inequality. What we haven't done is the next one. Solve systems of linear equations by graphing, substitution, and elimination. So let's do that. And that's a pretty tall subject. There's a lot to that. Let's talk about in general, let's talk about solving a system of equations by graphing. If I have that line there, and I also have, which could be represented by an equation, and I also have that line there, which can also be represented by an equation, the solution to that equation lies right there, wherever they cross. And it doesn't matter if they're linear or not. They could be curved. I could have 2 parabolas. In other words, I could have a parabola that looked like that, and I could have a parabola that looked like that, and that system of equations would produce 2 solutions right there. But graphically, when they say you're solving a system of equations graphically, that's what they mean. Now, if I went over here on the right, and instead of having that second line, let's draw a second line that's parallel to the first line. Notice that those 2 lines don't ever cross. So if you gave me the equation of that line and you gave me the equation of that line and said solve it, there is no solution. So just because two things are linear doesn't necessarily mean they always cross. They will always cross as long as they are not parallel. But in the instance they're parallel, well then they don't ever cross, so you don't have a solution for that. Now let's label these. That was the graphing method, and for the moment I'm not going to go into that much more. We'll save that and come back to it. The main two methods, and that's because the graphing method isn't very accurate. You could graph it, but if you don't read the graph exactly right, you're not going to get the nice, clean solutions. So that's why I want to come back to the graphing. The two primary methods that they teach you that you really want to learn for sure are substitution and elimination. Let me give you an example of both. There's the equation of a line. Okay?
Okay.
Now, if I also give you a second equation, in other words, when I have one equation and two variables, I can't really solve it. That is the equation of a line, but there are literally an infinite number of points on that line. So one equation never allows me to solve for it. But if I also tell you that x is equal to 1.5y, there's a second equation. Now I have two equations, two unknowns. Most of the time you can solve that system of equations. How would I solve it? If I gave you these two equations, how are you going to solve for both x and y? Look at the title, Substitution. Substitution basically means you're going to take one variable that's fully defined. This one's fully defined, x equals 1.5y, and we're going to substitute it into that equation. So wherever I come across x, I'm going to write 1.5y. So now let's rewrite that equation. We got 2 times, instead of x, 1.5y, plus 3y equals 12. Well, now we got one equation and only one variable. We can always solve for that variable. When you have one equation and one unknown, then it's just a question of doing the algebra. Well, this ends up giving us 6y equals 12, so y equals 2. And once you've solved for one variable, you can go back into actually either equation and solve for the other one. If I go back into the one that I've circled, x equals 1.5y, and I substitute what I now know y to be, which is 2, then I get x equals 3. So there's my two solutions, and you always have to solve for both variables. With me?
Yep.
Okay, let me change it up just a little bit. The way I like to do this is after explaining something, and then I'll give you a problem and let you tell me how to do it. So let's try that. And we're still on the substitution method. It sometimes is the easier method, sometimes it's not. First of all, let's change the equation up a little bit, make that equal to 10. And now I'm going to tell you that y equals 4x plus 3, not 3, 4x, yeah, we'll leave it 3, okay? Now, notice that this is a little more complicated because, first of all, I told you what y was, not what x was, but it doesn't matter. I still have one equation that's in standard format, and I have another equation that's completely solved for one of the variables. So what would the next step be if I'm using substitution?
You would substitute.
Give me the next line. Give me the next line.
Okay, 4x plus 3
Hold on.
plus.
Start from left to right. Okay? In other words, I don't want to start down here at the bottom one. I want to go back up into that equation, the top one, and whenever I come across y, I'm going to substitute 4x plus 3 in parentheses.
Okay, so
Tell me what
it would be 2x plus 3 parentheses 4x plus 3 equals 10.
Okay. Now, again, we've got one equation, one variable only. Let's solve this. What's the next step?
Distribute.
Read the next line.
2x plus 12x plus 9 equals 10.
And the next line.
2x plus 12x equals 1.
And the next line.
Could you add the 2x and the 12x together?
Yep, that's what you do, is you gather like terms. Those
Okay.
are the same terms. In other words, it's not 12x squared or 12x cubed. It's just 12 times x. That's 2 times x. You can add those together like that's 2 apples and 12 apples. That would be 14 apples. Well, only in this case, an apple is x. Okay? So now the rest of it's pretty easy. X equals 1 over 114. So that's the answer for x. Now how do I solve for y? Because you always need to solve for both variables here. And regardless of which method you use, whether it's substitution or elimination, you end up, your first answer is just one of the variables. You then have to go back and get the other one. Well, let me make a little room here by erasing all of this stuff that we no longer need. And tell me how you would solve for y if you know what x is. And you do know what x is. X is 1/14. So how do I solve for y?
Do 2 parentheses 1/4.
Easiest way. That's one way to do it, and that would work. But that's not going to be the easiest way to do it. Notice that this equation, we've got y equals. So all we've got to do is plug in 1/14 for x, do a little arithmetic, and we'll have y. Whereas if you go back to the first equation and plug it in, then you got quite a bit of algebra to still do. And it's going to involve fractions also. So it's going to be far more difficult to solve for y if I go back to that first equation than if I go to the equation where y is already solved for. Y is 4x plus 3. So if I want to know what y is, it's 4 times 1/14 plus 3. So I guess I could call that 3 2/7. So that's what y is. We got fractional results because I made this problem up. Normally you would get whole numbers, but
Okay.
you don't have to get whole numbers. In other words, there's nothing wrong with having to deal with fractions. Okay? So you use substitution whenever one of the equations is fully defined for one of the variables. And that's the case here. Okay? There's one other case where you would use substitution. And that's where both of them are defined in terms of one variable. In other words, if they tell you that y equals 6x, and they also tell you that y equals 4x plus 3, well, now we got both equations fully defined for y. Well, you want to use substitution still, but go ahead and substitute that for y in the next solution. So you would still end up with 6x equals 4x plus 3. Now you've got one equation, one variable only, you can solve for. It's always the key on these systems of equations is to try to get it down to one equation and one variable. Okay, and then of course this would be 2x equals 3, or x equals 3 divided by 2. Once you know what x is, you could go back up into either equation. Now, personally, I think the first one would be easier because now all I got to do is figure out what 6 times 3 halves is, and that's 9. All right, so that's the way you do substitution. And there's basically 3 types of substitution, and I just went through all 3 of them. And they might give you them in other forms, but usually when they ask you to solve it by substitution, one of the equations is going to be fully defined in terms of one of the variables. Now, let's talk about elimination. If you have both of your equations, and these two terms only come into play when you have a system of equations. That's the only time you're using words like substitution or elimination, okay? So I got to have 2 equations to use one of those methods. Well, let's say my 2 equations are the following. Now, notice first of all that both equations are in standard format. And by standard format, I mean the x and the y are both on one side of the equation and the number is on the other. That's called standard format. Okay, so is this one. My x and my y are on the left side in order, and I got a number on the other side. Now, when you have a situation like this, occasionally they'll be really easy to solve. I could take one of these equations and solve it for x or solve it for y and then use substitution, but that'd be the really hard way to go. There's an easy way to go. Equations can always be added or subtracted from one another. The reason this method is called elimination is because if I add these 2 equations, I eliminate one variable immediately. And do it. Add those 2 equations. What do you get?
X.
Huh? The x's go away. Notice that I'm adding a positive 2x to a minus 2x. That gives me 0x. That's the variable that gets eliminated.
Got it.
Now add the other two. In other words, when you add two equations, you're adding every part of each equation on the left and every part on the right. So what is 3y added to minus 2y?
It's 1y, which is just y.
And now I got to add these two also, because I've chosen to add the equations. I got to add both sides.
It equals 1.
See how easy that was to solve with doing almost no math. And of course, now we still got to get x. So I personally would go back into this equation and plug in y equals 1, giving me 2x plus 3 times 1 equals 1, giving me 2x equals minus 2, giving me x equals minus 1. So there's my two solutions. So I have to do a little bit of math to solve for the other variable, but elimination is really a beautiful technique to use because it's so quick. As long as everything is nice and simple and straightforward, elimination is very easy to use. Now let me change this. Make this my second equation. Okay? So I've got equation 1 and I got equation 2. Now, math says you can add equations, you can also subtract equations. Just as easily as I'm adding, I can subtract. And in this case, I want to subtract, right? Because if I subtract these two equations, the x goes away. It gets eliminated. And we'll be able to solve for y. Once you have a solution for y, you go back and you solve for x. So I want to subtract now. Well, 2x minus 2x is 0x. What's 3y minus a negative 2y?
1y.
No. You got 3y
Oh, because it's
minus
subtract.
a negative 2y. The biggest mistake that people make in algebra is dropping negative signs. I don't care if you've got 5 negative signs in a row. You don't want to drop any of them. Okay? And in this case, I had 2 of them. So dropping one of them gives me the wrong answer, always. You cannot drop negative signs. You have to count every single one. If you have multiple ones together, then use parentheses so you won't get confused. Okay? And now what's 3y minus a minus 2y? In other words, when you subtract those two, what do you get?
Could you say that again?
What's 3 minus a minus 2?
3 minus 2 is 1.
No, what's 3 minus a minus 2, which is our problem here?
It's 5.
Okay. So 5y, I got to subtract the other side. It's still 1. So y equals 1/5. Okay? So again, elimination was really easy. I just had to subtract instead of add. Well, a lot of people don't like subtracting for exactly the reason that you don't like it. Because it's easy to make a mistake. When you do 3 minus a minus 2, it's easy to make a mistake there. So they'd rather add. Okay? So let's say I'm one of those people that doesn't like subtracting and I want to add. Well, the other thing that math allows me to do is I can take either one of these equations and multiply both sides by -1. Okay, well, let's take equation number 2 and multiply both sides by -1. Turns that into -2x, turns that into plus 2y, and leaves that at 0. Now I don't have to subtract. I can add. In other words, merely by changing that 2x to a -2x, I've turned it into a situation where I can now add. Adding's easier than subtracting. I still get 0x. Now there's no question about what that is. I still get the same answer, just did it slightly different way, so that I would always be dealing with addition, not subtraction. Okay, and most students I have found almost always do this technique. If I gave them this problem, they would not subtract it. They would multiply one of them by -1, and then they would add it, the two, just because they're that much more comfortable with addition than subtraction. And there's nothing wrong with that. It's the same reason that I tell everybody to turn addition or subtraction problems into addition problems. How do I tell people how to do that? Well, there's your subtraction sign. The way you turn it into an addition problem is by making that plus and then changing the sign on what was being subtracted. So you end up with 3 plus 2, which is 5. As long as you have a bunch of plus signs in a row, then it doesn't matter how many of them you have. But if you have a bunch of minus signs in a row, you need to count every single one of them. Okay, Phoebe, you good to go for today?
Yeah, thank you so much.
Yeah, you're welcome. And then Friday again at 3?
Yeah, that sounds good.
I will just text you the meeting ID number, and we'll pick up from this. We'll do a little bit of review. This is a pretty lengthy topic here, solving systems of equations. Even though they only had it in 2 places on this thing, that's a couple of weeks worth of math if you're in an algebra class. Not all of these are. Some of them can be taught in 5 minutes, but that particular item there, that was at least a whole session and maybe a little bit more of another session. And if you can get your graphing calculator, we can always do that later. But at some point, you're going to want to pick up that graphing calculator. I suppose that you don't have to know how to use that before you start school. In fact, they'll probably start you out and they'll give you a couple of classes on the calculator to teach it to you. That's my guess. Regardless of what subject you're going to take, whether it's algebra or geometry. Maybe not. They might expect you to be able to use a graphing calculator right off the get-go in order to decide which class to put you in. And if that's the case, then you want to pick one up sooner rather than later so that I can at least help you do it a little bit. I can help you get started on it. Okay? All right, Phoebe. I will talk to you on Friday.
All right.
Bye-bye.
Bye.